Hi everyone. 12.5 and 12.6 are going to be combined together in this one video lesson. 12.5 is surface area of pyramids. 12.6 is surface area of cones. So we'll first talk about 12.5, surface area of pyramids. Let's label certain parts of a pyramid, which I'm sure you already know a lot of these parts, but there's maybe a couple that you haven't learned just yet. You've learned this where all of the lateral faces meet, all those triangles meet. That's called a vertex. Where this red arrow is pointing right here, that's the height of the pyramid or the altitude. It's the blue arrow is pointing to the blue triangular face, and that's called the lateral face. So that's a lateral face. The yellow base, that pentagon, we would call this a pentagonal pyramid because we label it by its base. So that's the base of the pyramid. The brownish line, that's where two lateral faces meet, and lateral faces meet in a line called a lateral edge. And then maybe the one that you haven't learned just yet is basically the height of the triangle. If I were to make a net of this pentagonal pyramid, I'd probably draw the pentagon base. And then I would kind of almost peel this like a banana. If you kind of picture this being the top of the banana, and I would just peel it down each way, and I would have 5 different triangles. So it would look like this: 1, 2 triangles, 3 triangles, 4 triangles, 5 triangles. So what this green line is pointing to right over here, this green arrow, it's pointing to the height of the triangle. So it's pointing to this height right there, or this height right there, or this height right here. So actually what I should have is I should have a 90-degree angle right here, because that would be 90. And because it's called the slant height, and a reason why they call it the slant height, again, it's the height of the triangle, but the triangles, all the lateral faces are all kind of slanted towards the vertex, so that's why it's called the slant height. And it is significant. The reason why is because the surface area, so the surface area of any pyramid, the surface area equals the area of the base, and then you would add that to the lateral area. And the lateral area is a bunch of triangles. And the triangles are 1/2 base times height. So you have to have that slant height because you have to have 1/2 base times height to get all of those triangles. So here's our first example problem. It says find the surface area of the right regular pyramid. So we're given that the height of the pyramid is 4, and it's a regular pyramid, so it's a regular quadrilateral, or we'd call that a square. It's a 6 by 6 square. So if I could make a net of this, it would look something like this. A 6 by 6 square. And then again, I would peel back all those triangles, almost like a banana peel. And all of those triangles are going to be congruent. Okay, so if we just find the area of one triangle, we could find the area of all 4 of them. So what we need here, class, is we need the slant height of the pyramid. We need that slant height because that is the height of all of our triangles. So how are we going to find that? Well, right here, we can now do I kind of drew that pretty off. We can now have a right triangle within our pyramid. Okay? We have this side is 4. This side right here is 1/2 of 6. So it is 3. So now we can find the slant height right there. So I'm going to call that x. We could have 3 squared plus 4 squared equals x squared. So the slant height of our pyramid, 9 plus 16 equals x squared. 25 equals x squared. So x equals 5 when you square root. X equals 5. So this height is 5 units. So now I can easily find the surface area. The surface area is the area of the base. So the area of the base is 6 times 6. Base times height is the square. Plus, we would have 1/2 base times height. The base of the triangle is 6. We're talking about this triangle right here. So the base of the triangle is 6 times the height of the triangle, which we found to be 5 by doing the Pythagorean theorem. And then how many triangles are there? There's 1 triangle, 2 triangles, 3 triangles, 4 triangles that are all the same. So we're going to multiply that by 4. All right, and that's going to be our surface area. 36 plus 6 times 5 is 30. Half of 30 is 15. And 15 times 4 is 60. So our surface area, here is the area of the base, here's the lateral area of all the triangles. So we add that together to get 96 square units. And that is for our pyramid. Now we're on to our cone. So if we try to find the surface area of a cone, again, it's kind of nice to look at the net. If you take a look at the net of the cone, we kind of get this circular base. And that makes sense, right? So we're going to have pi r squared. For the surface area of any cone, it's going to be a pi r squared, because that's the area of the base. Now, if we kind of unravel the cone, or if we unfold it so it's flat, all depending on how tall the cone is, it's going to kind of look like what I call like a Mrs. Pac-Man kind of a thing. So that's going to be the surface area of the cone, is the area of this one plus the area of this one. We already said that this one is pi r squared. And now you'll just have to take my faith here with me. I'll try to explain this in class. But this sector part of the circle right here is going to be pi r L. So the surface area is pi r squared plus pi r L. Now you're probably asking what L means, right? L is the slant height of the cone. We learned that the slant height on the pyramid was the height of the triangle. The slant height on the cone is almost kind of what you think of it. It's the slanted distance. So there is the slant height. Okay, so the radius is right here, of course. And then the slant height is that slanted, that vertical or the diagonal distance from the base of the cone to the vertex of the cone. Okay, so that's the surface area of any cone. So now if we talk about what is the lateral area is the surface of the cone, the surface area of the cone minus the base. So we're not going to have this pi r squared. All it is pi r L. All right, we have one problem with this one as well. Find the surface area of the right cone. We know it's a cone, so we know the surface area is going to be pi r squared plus pi r L. So knowing that, we do not have the radius, do we? Again, we could use Pythagorean's theorem, and then we could find the radius. There's a right triangle. So we could say radius squared plus 24 squared equals 26 squared. The hypotenuse is 26. It's also called our slant height. So continuing to solve, we would get r squared plus 576 equals 676. Subtract 576. The radius squared is 100. So square root 100, the radius is 10 units long. So this r, we now know, is 10 inches. Now we can put it into our surface area formula, because we have radius and we have slant height. So the surface area equals pi 10 squared plus pi 10 times the slant height. Remember, the height of the cone is 24. The slant height of the cone is 26. And L is the slant height, so it's times 26. So the surface area equals 100 pi plus 260 pi. Add 100 pi plus 260 pi to get 360 pi. And this would be our answer in exact units or exact square inches. If we approximate by multiplying by the pi button, 360 multiplied by pi, and we would get approximately 1,130.97 square inches. That concludes our lesson on pyramids and cones for surface area.